So good morning, good afternoon, good evening, wherever you are. Welcome to the GMT UNAVCO. Welcome to the GMT UNAVCO workshop. I'm Paul Wessel, and we have with us the instructors, Eric, Megan, Dong, Joachim, and Leo today. And you will see more of those as we proceed through the workshop. So as you know, there's two groups here. There's one group that are on the Zoom call, and then there's another group that is watching this live on YouTube. Both of you have access to Slack and GitHub, so you can communicate with us through those two mechanisms when you have questions. We'll be monitoring both. So just sort of very briefly, what we're going to do today, we're going to have several sessions. It's going to be a mix of a little bit of background lecturing from one of us, and then we do some demos together, and then there is a task that you guys are going to be completing in the breakout groups, and you will have help from one of us in that group. Plus, you can again post questions on those two sites. And especially if you're stuck with something, a quick question, best to post on Slack. If you need to show us a larger portion of a script and that's problematic, maybe better to open an issue on the GitHub site. So we're going to very soon test the breakout rooms. That will be sort of set up randomly, but then we'll keep the layout for the rest of the day, I guess. And so you get to know the people that you're going to be working together with. We're going to see the schedule will be a lot of breaks today. I'll just briefly show my screen here, so we can see the schedule. All right, so hopefully you can see my screen here. The schedule, I'll say a few things here in the welcome session, and we'll do a icebreaker in the breakout rooms, and then I will be talking a little bit about Unix and Bash, and we will do some examples together. And then we have a lot of breaks, as you can see. So these breaks of various lengths will allow us to certainly catch up on the time schedule if we go a little bit long, but also give you a chance to get away from your screen and get some coffee or a meal or something, especially with a long break in the middle. And then we will continue. So we'll try to stick to these schedules, and instructors that are not talking should be mindful of time and prod the person who is going over time, including me. So we'll do that. After this course is over, please continue to be part of the community and post questions on our GMT forum and contribute bug reports to the GitHub site. We are only as good as the totality of the community, and you'll be part of that. For this session, we're going to be all using a Bash terminal, and all the instructors are going to be using Visual Studio Code to sort of demonstrate how things are. We're going to write script, and we're going to run them on the command line. And so I sort of talked about all these rules during the intro session like a few weeks ago. So there's nothing really new here. Remember that we were operating under the UNAVCO Code of Conduct. So we're supposed to be nice to each other and not use swear words and cuss at the GMT developers for making things complicated. I can do that later. Send me an email. That's basically the highlights of what I'm going to talk about here. So I'm going to stop my screen here, and we're back. So I think we should try the little breakout feature and just exercise how that works. Melissa, do you want to throw us into the various groups?
Give me 1 second here.
So it might be good to give some instructions first.
Okay.
So what are they supposed to do in the groups?
Oh, we're going to introduce ourselves to each other. It's just see who they are. So I think we are 45. That includes us. Mm-hmm. So since we are 1, 2, 3, 4, 5 instructors, I don't know if we should divide it into 5, or if we should have more groups and hop around. Any thoughts on that, Leo?
Yeah, if everyone's supposed to talk, then I would say at most 5 people per group, because otherwise we're gonna be there for 40 minutes before everyone can introduce themselves.
That's true. That's true. Okay. Can we do that, Melissa? Can we do 5 in each group, or is that too late?
No. Let me see what I can.
So no need to get your text editors out yet.
Okay. So that would make it eight rooms. Is that okay? All right. Let me open those rooms, and we'll go from there.
Okay.
To those of you just joining, we were testing out our breakout rooms, so people should be coming back shortly. Oops.
Dora, I think we got
Apologies.
kicked out of the rooms.
Sorry.
Just getting started.
Yeah, no worries.
I meant to have it go 1:30, but
Sorry for anyone who got cut off there. We can continue that when we go into our next breakout rooms after the next session. So anyone who didn't get a chance to introduce themselves can continue then. Paul, are you speaking? I think you're muted.
I am sorry. So it switched me to mute again. I didn't do that on purpose. Well, I said a lot of things, but I can't remember what they were, but they were inconsequential. It was just about the breakout room and the quickness of the exit. All right. So we will continue, as Megan said, we'll continue meeting folks in the breakout room as we go along. So I think any instructor want to say some sort of broad statements here that I've forgotten to say before we delve into the Bash Unix session? Anything I forgot to mention?
Yeah, I'm not sure if you mentioned that we'll take questions through Slack specifically. So please don't post your questions in the Zoom chat because it's much easier to track on Slack where we can use threads to answer and keep track of who we're answering. So you can use the general channel to ask any questions in the Slack workspace.
Yeah, it's very good. We had trouble with using the Zoom chat last year because that's a messy system. So we do not want to encourage that at all. Anything else I forgot? Probably lots of stuff. All right, are you all psyched for this? You all got, we assume by now you have a fully functioning GMT running laptop desktop. There's no time to recover any problems. So I think we will just go ahead, I think, with the first session then, since we are about a few minutes early. Okay, so I'm gonna share my screen here. So you should be seeing my screen. Right now, you just see the program. So you can see we have a tight schedule here for you. I can open my slide here. And you should see my lecture notes. So, okay, so we're gonna talk about very basic Bash and Unix things that you need to know. And most of you, maybe, hopefully not everybody, but most of you will probably know a lot of these things. This is not gonna be advanced at all. But we just want to make sure everybody is on the same page when it comes to terminal skills. If you are still fresh on Unix terminal stuff, just take a class from the software carpentry guys. There's very good, lot of courses you can take online there, free. All right, so the goals for this little session is to just summarize some of the basic Bash skills that you need to run things in this course. And then we're going to try some of these commands in your terminal. So it'll just be very basic things. And I'll just have 7 slides to sort of summarize everything you need to know about Bash, at least the highlights. There are way more things to know. And we're not going to really get into programming Bash. We're just going to basically use it as a little application. So here's the skill set that I hope you already have or will learn during this short presentation. So how do you navigate your directory tree from the terminal? Going up and down, folders inside folders, going back to the home directory, that sort of thing. Then we have the redirection. So this is Unix way of redirecting output or inputs to come or go to different sources and destinations. And that's sort of critical to know. We'll see how can you examine what's in your current directory, creating files and destroying files and directories from the command line. Typically, we'll do this inside scripts, but we do it on the command line as well. And then how do you run your script from the command line that you've been putting together? And then a little bit about how to use shell variables, and why do we want to do that, for instance. So that's sort of the basics. It's very simple. All right, redirection. So this little scary slide here just summarizes all these different ways. So most Unix programs, and that includes many of the GMT tools, basically are set up in the same way in that they read their input from what's called standard input, stdin, and that's by default the keyboard. So if you just run a program, it might expect you to type the answers or the data. Of course, we're not going to do that most of the time. So we need to redirect that. And same thing, it may write the output to the terminal, but you may want to send the output to a file. Okay, then we have to redirect it to a file. And the third thing that comes out might be error messages or warnings or something. And they are sent also to the terminal, but they're actually sent to a different channel, and you can redirect that independently. So you'll see the first line here with the left and right pointing arrows. Those are the redirect input and redirect outputs in various ways. I'm not going to go through all of them here, but basically, if you have this slide handy when you need to do some of these things, it should give you everything you want to do. And we're going to try some of these in the demo here. But there's a lot of ways to put these things together and build processing chains. And it's very easy to miss one of these things. If you do 1 versus 2 redirects, for instance, you will get a surprising result where you clobber your file instead of appending to it. So confusing in the beginning, but it's very powerful and let you build very complicated scripts. Navigating directory tree, we have a couple of commands that are handy. cd, which stands for change directory, is how you change where you currently are working. And then if you get lost, pwd, print working directory, will tell you where are you right now. And then there's different ways to navigate. If you just type cd, you get to the home directory. I have to give a full path, for instance, with a tilde, which means the home directory. You can start from the home directory and go down a tree. Or if you are in the directory and you have a subdirectory, you can say cd into that. Double dot means the parent directory. So if you want to go up one step, you do cd ... and it will take you one step back. We'll exercise these things shortly, but it's sort of very basic commands of moving up and down. You can, of course, do the same thing in a file explorer or something. You're probably all familiar with that. But when you are in the terminal, you kind of want to change the directory you're working in, and then you have to do that from the terminal. All right, so you're going to be in a directory. You want to see what's in it. The typical command is to run list, or ls. So ls will show you everything that's in the subdirectory that you're in. ls is a program, it's a Unix program, so it will take options. And there's tons of options. We aren't going to explore that. If you want to see them all, you do a man page on ls. But sometimes you do ls minus l to get a little bit more information about who owns the file, how big is it, what's the permissions, that sort of thing. ls will just give you the names. It can take wildcards, so you can list just certain kinds of files. And of course, it's a Unix program, so you can redirect the output to, say, a file. Or you can pipe it through some other command to just, to do a subset of the outputs. We will try all these things. So this is typical Unix workflows, doing quick things on the command line. If you have 2,000 files in the directory, you just want to look for PDF files, you will use one of these commands. All right, creating and destroying files and directories. So the tools, the commands that Unix has here are mkdir for make directory, rmdir for removing directory, and just a general rm for remove that can be used for directories or files. So typically, you'll make a new directory with mkdir and give it a name, and that creates an empty subdirectory where you are right now. And you can delete that with rmdir, provided the directory is empty. If there's stuff in that directory, you can't delete it with rmdir. You have to use rm for that. rm is powerful. It can delete anything you give it. It will typically ask you, are you sure, before it deletes it. Those of us who like to live dangerously will throw in the -f option, which forces the delete without asking questions. You should be careful doing that. You should know what you're deleting. If you want to delete directories, you have to use the -r option with rm. And then everything inside that directory, plus the folder itself, will be deleted. All right, running scripts. Now, for most of the, I think all the examples we're going to do, we're going to create a script, and then we're going to run the script using the bash command. So as you see here, I have a list of ways to run scripts. So we're going to use the first one, which is the simplest. Just run the command bash and give it the script as input, and it will execute. There are many other ways to run it. If you want more feedback, like printing out what's inside the script as it runs, you give it the -xv options to bash, and we'll sort of show you each line as they go through, and that can be helpful for debugging if you have variables. If you change the script to have executable permission, the top line there with change mod, then you can run it as a program because you changed it to an executable application. So that's sort of step 3 there. You can just use it as if it was executable. If you then get messages like script.shell not found, that means that your path does not contain the current directory. So that's very often the case for folks when they have an initial path set up in a Unix system. Then you have to do period / in the name of the script, meaning the period means the current directory, and double dot means the previous, the parent directory. That will always work if you have made it executable. But as I said, we're going to stick to option 1 here and run scripts with the bash command directly. Okay, and finally, my last slide, we'll set and use shell variables. So different shells have different syntax, and here's the bash shell syntax. You pick a variable name, and you do an equal sign, no spaces, and then you assign whatever value you want that variable to have. So here, for instance, I say width equals 15c. So this might be a variable that I want to use in a GMT script that sets the plot size to 15 centimeters. The reason for doing this is that maybe that number appears many times in my script. Maybe I'm making many plots. And then later I decide, it really should be 12 centimeter. It's way easier to change that one line to 12c than to hunt all the places where it might say 15c in the script. And you forget one, and then there's all problems with the plots. So sometimes it's much better to use variables for things that you may actually change later. To use a variable, you'll see that I'm using the $ symbol and curly brackets around the variable name. That's foolproof. That will always print out the value of that variable. If you leave out the $ entirely, then you just get the text string width. And the last example there shows a more complicated bash command where I want to find what's the name of my lastly produced PDF file. Well, I run a subshell inside $parentheses. So inside $parentheses, I run the ls command, pass a -t to sort on time, look for all PDF files, and then that long list is piped through the pipe symbol, through the head command, which I give it N1, just give me the top file that's piped in, and that's being returned and assigned to the variable last PDF. So now my script, if I did this in a script, can print that file or delete it or email it to someone or whatever I wanted to do. So you have a lot of power in basic bash commands once you get a handle on how these things work. All right, so that's sort of just the highlights of what I wanted to show there. What we're going to do now is to try some of these things in our terminals. So I'm going to start and use Visual Studio Code. That's what we recommend you do too. But if you already have your own favorite terminal, just knock yourself out and use whatever you want to do. It's okay. So I'm going to start sharing again my Visual Studio C. Actually, I'll do the desktop again because there are things I will share that won't show up otherwise. All right. So most of my screen now is taken over by a black triangle with some white text. I hope you all see that. Can someone give you a nod? Leo, you can see that? Yeah, very good. Okay. So this is what Visual Studio C looks like for me. I think you can configure it in different ways. So, but I have, on the left, I have a little listing of directories. On the bottom half-ish there, you'll see I have a terminal. You can open a terminal from the terminal menu of Visual Studio Code. And then there's a blank space here where I have an editor. So I'm just going to try some of these commands that I just talked about. So I'm going to start in should have cleared this. Okay. here's my terminal. Where am I? Well, pwd will tell me where I am. So I am in /users/pwessel, which is on a Mac, the home directory of the user pwessel, which is me. So that's usually where things start out. To see what I have in that directory, I can use the ls command. And I have a bunch of stuff, a lot of files in my directory because I'm messy. I don't delete stuff, so it just piles up. This is too bad. I want to see where are my PDF files. ls star.pdf. Okay, I have a bunch of PDF files in that directory. And I could, look for shell scripts, ls star.sh. Usually use the extension .sh for shell scripts. Oh, yeah, I have a bunch of shell scripts in that directory too. So if you have a cluttered directory, you can look for subsets of your files just using these wildcards. Star is usually the favorite, but there are also question mark for a single character and more complicated things that we're not going to talk about. If I want to find that most recent map that I made, I will do ls-t, which sorts on time. So the youngest files come up first. So now it's organized in that way. Still a lot of files. I just want to find the most recent one. So I redirect the output from ls through another program called head, which is a super simple program that just displays a certain number of records. And here I want just the first record, -n1. And it says map.pdf. So that is the most recently made map. So if I made plots and I forgot what they're called, I can find them based on time. There's a Unix program called find that has lots of options to really nail down specific things, even based on the content of files. But we're not going to go into that because that's a very complicated Unix program. All right, where am I? pwd. I'm in my home directory. I'm going to create a directory with mkdir, mkdir. I'll call it GMT course, maybe. So I'll just give it a name. Okay. Did anything happen? I can't tell because so many things here. ls GMT course, maybe? Notice I'm going to type GMT course and then I get tired of typing and I hit the tab key. It will complete what starts out with those letters if it's unique. So very often you'll find yourself using the tab key to complete names of files that you kind of know start with a certain combination of letters. Okay, so it found GMT course. It appended a slash at the end, which tells me that it's a directory. I can do an ls on that. And it has nothing, of course, because I just created it. So I can go into this directory, GMT course tab, ls there. It has nothing, of course. Let's make a file in there. I'm going to make it by running the ls program, ls, and I'm going to, there's nothing in there, right? So I need to list another directory, and I'm going to list the parent directory, which in this case is my home directory, but I can do this, ls ... That's going to be my previous, or the directory above me. Or I could say ls tilde, which is the shorthand for the home directory. These will be the same thing. But the ... is always relative to where you are, versus the tilde is an absolute path that goes to your home directory. So if you need to rerun the previous command, you can use the up arrow keys. To type it again, you can go back and forth for the most recent commands. I'm going to do the ls ... and I'm going to save the output by redirecting it to a file called list.txt. Hit return. So now the output that normally goes to the terminal is instead sent to the list.txt file. And I can do an ls now without any arguments, and it should show me the content of the directory, which now has a file, right? So now I created a file in the directory, I have it. I want to open that in my editor here. So I go to File menu, Open, Now I got to find where I am here, home directory. So this is just navigating through the menu here, GMT course. There it is, list.txt. I'm going to open that. Yeah, trust the author, yes. Remember my decision. Open. Okay, there's my file. That's my listing. I can scroll through it here, and you can see, unlike in the terminal here, where it gave me several columns of files, when you redirect to output here, it put one file per line, which is very useful most of the time. So I had, how many do I have here? Go to the bottom. I had 281 files in my home directory. Most of them look kind of obscure. I can edit this file, of course. It's an editor. I can delete a whole bunch of files here. Doesn't really matter. Delete these guys. Now I'm down to 72. Well, that's too many for me. Let's just randomly delete a bunch of files here. All right. Save that. Back in my terminal, ls, nothing has changed there. How do I look at that file in the terminal? Well, there's two ways. There's a command called more, list.txt. More will display what's in the file, but one page at a time. So you can see it shows the beginning of the file, and then it sort of stops and waits for me to hit the space key. It will continue to the next page and so on until it hits the end. And we're done. That's one way to display it. The other one is to use the cat command, which stands for concatenate. Complicated. List.txt, and it will print that file to the screen without pausing at the page boundaries. All right. This file is not particularly useful. I want to delete it. So I can use rm list.txt. He's going to ask me this question. And that's fine. You know, okay, I can say yes or no. I'm going to say no here. Okay, good, it didn't delete it. If I'm bolder, I will remove -f, list.txt, and there will be no question asked. So there's no recourse if you hit return now. Now, the reason I often do this is that when you write scripts, you aren't necessarily there to answer these questions when you run the script, right? You might run the script on the weekend or something. It takes a long time, and then it's going to delete the temporary file. You don't want to hang because of this question. So I often put in -f and trust that I've done the right thing. It's gone. Okay, let's try a variable assignment. So I had something like width equals 15c earlier. Okay, ls, nothing, because I didn't create a file, I just had a variable. So how do I see what the variable is? Well, I can use echo. That's one way to do it. Echo is a command that just prints back, that's what it says, it prints back what you give it. If I say echo width, which is name my variable, I just get the text width because that's not how you access the variable. You have to put a $ in front of it, and I will recommend you always put the variable name inside curly brackets because there are times when that is actually required, but in this case it wouldn't be, but get used to that habit. Now I can print out the value. And the way I would use that in GMT would be to pass $width where I might expect a map width to be placed in the script. And because that might appear many places, using that variable assignment near the top of your script is pretty good style. You can easily change that one thing and the whole script will change accordingly. All right, I'm gonna do, ls again, just demonstrate appending to files. So if I do my ls ... to list.txt again, we know that we create this file of, how much was it? 200 and something lines. How many lines does the file have? There's a word count program. I have 281 files. Okay, that's a lot of files. If I use the double redirect, 2 arrows, that means append to the file. So single redirect means start a new file with that name and put whatever goes in there. Double redirect means append to it. So now I have appended to the file, and the length of the file is doubling because I'm putting the same information twice. I can keep doing this until I get bored of it. So I can just keep adding to it. So you can see if I meant to add to a file and I put a single redirect, then of course I'm clobbering it and starting fresh. So as you build data files, you got to be very careful using the append versus the create file. It's like typical rookie error to make that little mistake, and then you get something unexpected. Where am I? PWD. I'm in my subdirectory. I'm gonna move back one here and list my GMT course subdirectory. Now it has a file in there. What if I want to remove my GMT course directory? Well, we had two ways of doing this: rmdir, GMT course. Ask yourself, is this going to work or not? Before I hit key here, make a bet. No, I can't delete a directory that is not empty with an rmdir. So it has a built-in safety mechanism, I guess. If you want to make sure you never delete the directory unless it's empty, you should use rmdir. But in my case, I just create this directory. It has junk in it. I don't care. I have to use rm-rf or r for sure to delete this directory. If I do rm-r, it's gonna ask me if I want to, do I want to go through file by file in this directory and delete them? Okay, I can't remember what's in that directory. It will now ask me for every file in that directory, which might be hundreds or might be one. Do I want to delete this file? Yes. Okay, that was the only file, right? So now it asks me, do I want to delete the directory? Yes. Okay, it's gone. ls GMT course. Tab doesn't work because there is no such thing. I spell it out because I'm stubborn. Still nothing. There's nothing. I deleted it. So this is sort of the basic of the Unix commands that you kind of need to work around here. PWD always helps you to find where you are. ls gives you the content. And I should have said one more thing here. You will typically have a mixture of files and directories in a directory, so subdirectories. To see what you have, -ls-l gives you a longer listing. Okay, so I'll do that here. And now you'll see there's a whole bunch of things that happens. You'll see the name of the file to the right, the end column, but there are a whole bunch of other things. There's the time information, the last time this file was created, or when it was created. There are the numbers, the integer numbers here are the size of the files in bytes. That can be useful. The pwessel and wessel is sort of Unix group information. So pwessel is the owner, that's my account. Wessel is the Unix group that this account is within. And then I can't remember what that one stands for, but the left stuff, the cryptic RWX stuff, are the permissions of the file. And so you can have read, write, or execute permission in different settings. You can be the owner, you can be the group, or it can be other people. You can see that I have RW for the left part, that's me, and I can do a lot of stuff. If I scroll up a little bit here, you see some entries starts with a D, and those are directories. So I have a directory called test here. And I think I have more than that. It's not a directory. Plot color test. There's one called opt. Right, so you can tell what these files are, and some of them will have X's on them, executable. Here's a script that I made executable. I can run this as a command because it's made executable. All right, how am I doing with time here, Megan?
You are about a minute over, and
Okay.
we have a 15-minute break after this. So
yeah, I think I'll stop there. It's sort of very basic stuff. You're going to be doing the same things once you are in the working on the GMT part of things. So I will stop sharing right now. I should mention again, but you heard this before, that all these sessions are recorded. They will be available on the UNAVCO site. So if anything went too fast for you, which will happen, you can always go back and review what's said and what was done. So these will be posted after the workshop, or at least tomorrow maybe, for today's session, because it takes a little while to prep things. Okay, so I think we take the break, as we said we would, try to stick to the schedule, and we will be back in about 15 minutes. So we should be back at 1750 UTC, which is 7:50 a.m. my time. Okay, we'll see you in a bit. Take a break, get some coffee or tea or whatever, and we'll see you in a bit. All right, I will take a break too.
Hey, Paul, before you go.
Yep. Sure.
Just real quick, are you posting your presentation somewhere? Or is it
Yes.
just the recording?
That should be, what's a good point? I think there's a link on our GitHub page.
I'll post the link on the Slack chat as well.
Yeah, okay, do that now. I think maybe we haven't posted that yet. Slides, video slides.
It's up there.
I'm looking at the GitHub page for the README, and it doesn't have actually active link to the GitHub, to the Google Drive. We should probably put that in there.
I can update it. It's still for 2020, so I'll just post a new link and put that in the chat real fast.
Yeah, great.
The link to the slides are there if you click on the bash folder.
Oh, that's.
And there's a link in there.
Oh, they're there. Thank you. Yeah. Got it. Thank you both.
Okay. All right. Yes, we're back on schedule at what is that, 1750. So I guess Megan is up next.
Yep. So in this about 80-minute section, we're going to cover some fundamentals about GMT. I will not be talking for 80 minutes long. We're going to start with a short presentation similar to Paul's section. Then I'll go into a short demonstration, and then we'll go into our breakout rooms and try our first GMT scripts. You've run some in your homework, but these will be new and exciting. So let's get started with the presentation portion. And I will just share this one window. So if anyone cannot see a single window that says GMT basics on it, let me know. So the goals of this section are to understand how GMT sessions work, how to create a basic figure, and how to create multiple figures within a single GMT session. This is a bit of jargon associated with the GMT program. So after we'll get into this, you'll understand a little bit more about what sessions are and some of the other language that's GMT specific. And we'll also cover how to make different subplots. As we're going through, in particular, the breakout sections, there's some resources that will be quite helpful for you. So I'm going to jump over to Firefox so that you can see exactly where these links take you. And someone can, the link for this presentation is in the repository, which I'm sure someone can post on Slack for y'all to get to. So let's take a quick peek at the GMT documentation site. Okay, so Paul, can you see the GMT docs homepage?
Yes, sorry, I was unmuted.
Okay, sounds great. So I'll just show you where each of these links take you. These are probably the most common places you'll navigate to on the GMT documentation. So over here under reference documentation, we see this modules link. These show the name of all the modules. There's many of them that you can use during GMT. And module is one of these GMT jargon that we use all the time. It's just like a command or a function or a method. It's something that you call within GMT. It's not exactly the same, but it's very analogous. So you can think about it in that way. So we'll call these GMT modules, and there are commands that you call using the GMT program. You'll also find yourself oftentimes needing to refer to common options. So we can go back to the home page. And similarly, in this quick link, we can click on common options, and you'll possibly have to navigate from this table many times to remember what all the different arguments to these different options do. The last one I'll give you a quick preview of is the default settings. So when I navigate around the GMT documentation, I often go back to this home screen and then click on from quick links, the default settings. And this is something you could skim through once, but oftentimes you'll just do a search for a keyword about what you want to do. For example, annotation or tick will help you navigate to whatever settings you want to use. So that was a quick demonstration of the GMT documentation, just so you saw what these different resources look like. And we'll go back to the presentation now. So each time you want to make a map, there's a few different selections you'll need to make. And in particular, you'll oftentimes need to set your region or the bounds of the particular area that you want to process data from or plot. And this is one of the GMT common options. So if you need to set the region, it's always used with -R. Then you, in particular plotting modules, you'll oftentimes need to set the projection. This is, this is how you draw coordinates on the Earth onto a flat plane, requires a projection. And so for most GMT plotting modules, you'll set the projection, in particular using -J. And then lastly, you don't need to draw a frame, but it makes a better map if you do. So the -B option in GMT is always used to control how the frame is plotted. And this is one of the most fun, powerful, and possibly painful options in GMT. So you can get into have a lot of fun or get into quite a bit of trouble using the -B option, but we'll just provide some of the most simple examples for how you can use this to draw a frame. So now that we've covered what the different settings are that you'll need to control, we'll go into a little bit more detail in particular about projections. So as I mentioned, you need to choose how you're going to plot geographic coordinates onto your computer screen or a sheet of paper. And in general, there's 3 different classes of projections that you can use to do this. There's the azimuthal class of projections, conic, or cylindrical. For azimuthal, it's as if you're having a flat sheet of paper tangent to the globe, and then you project from the center of the Earth onto this sheet of paper. For conic projections, it's analogous to forming a cone from a sheet of paper and projecting from the center of the Earth onto this conical sheet of paper. And then lastly, for cylindrical, it's similarly as if you make a cylinder out of a sheet of paper and then project outward. And there's a lot of different options within each of these classes for exactly how you do that projection. In GMT, we support 30 plus different projections, and from the GMT documentation homepage, you can get to a table that shows all of our different projections. Through a Proj interface, or you can also use many more different types of projections. So there's a good chance that you can get to use the projection that you want to use while making a map in GMT. In addition to these three major classes, there's also another set of projections that use different strategies for plotting the entire globe on a sheet of paper. You can maybe imagine why these azimuth-philoconic and cylindrical each don't work for that. So there's other options and a few that are that we'll go over in this first demonstration here today. All of the different projection options that are supported directly by GMT are described in the cookbook, and you might want to read through that the particular projection you want to use, but it's nice to know some information about how these different classes differ and what your options are out there. So now we'll cover some basics about how a GMT modern mode script works. If you have used GMT before, in particular prior to GMT 6.0, you used classic mode, and modern mode differs in some substantial ways. We're not going to go into all of those details because there's probably many people here who have never used classic mode. So to not bog people down, we're just going to cover from the start how to create a modern mode script. So this beige box shows example of the format you might have for a GMT modern mode script. This top line, the hash exclamation user bin inf bash, is something that you put at the top of your scripts just to let your system know to use a bash interpreter. There's shorter versions that you can use for this command. For this first getting started section, we'll just use this particular version to specify that it's a bash script. Then you set up your GMT session. And this is always done using GMT begin as your first command and GMT end as your last command. And this is the general format that will be used to call all modules from the command line. You have GMT, the program name, begin, your module name, and then any options or arguments that are passed to those different modules or commands. So here we have the session name. It's outlined in brackets, and those brackets are used throughout both our presentations and the GMT documentation to indicate that it's optional. So you can have a GMT session start using GMT begin without passing the session name, but it's a useful feature in particular because if you create any figures, it will be the prefix for that file name. Then if you're creating any figures, you can also optionally pass the graphics format as a comma separated list. For example, you could do PDF, PNG to create a PDF file as well as a PNG file. In the middle between GMT begin and GMT end, you'll have any number of GMT or Unix commands that you want to run, and you'll see this in more detail when we go over a demonstration. One useful optional argument to the GMT end command is the show. So if you type show, it will automatically open any figures that are created within the GMT session when the session closes. So that's something that I usually add to my GMT script so that you can you don't have to find which file you made in your navigator of choice. So it's quite useful function. So this is how most modern mode GMT scripts look. You start with this line showing that it's a bash file and then have GMT commands surrounded by GMT begin and GMT end. So now we're going to jump over to a demonstration for a map of Italy. So I'm going to stop sharing this presentation and jump over to Visual Studio Code. We should have closed some windows first. Give me 1 second. I was asking for confirmation while muted. Paul, can you see Visual Studio Code now?
Yes, I can see.
Okay, great. So let's get started. So in this first example, we're going to be creating a map of Italy. And if anyone is unable to read this window, if they need larger file sizes, you can just ping in the Slack channel. So to start off, we'll create a new file. And you won't be able to see this window, but all I'm doing is saving this as italy.sh. Any file extension would work, but .sh is nice to denote easily that it's a shell script. So we'll add that first line, hash exclamation user bin in bash to specify that this is a bash script. And it's helpful to have a comment at the start of your file to specify to provide some information about what the script does. So we'll say make a map of Italy, and this is useful for when you create 1,000 GMT scripts and you need to know what does what, or if you need to quickly search for a given file. So as we saw in the presentation, we generally set up a GMT session using GMT begin at the beginning and then GMT end at the end. At the beginning, we can add a prefix. So we'll call this Italy, and this will be the name of the figure that's created by this session. And then we'll make this a PNG file. At the end, you could type show in order to automatically open this Italy map in your default PNG previewer. I am going to comment this out so that I can show you it in Visual Studio Code, but for most cases, you will want that show at the end. For making our first map, we're gonna plot coastlines, and that's done using GMT coast. So we'll need to supply some options and arguments to coast in order to specify those map characteristics that we talked about earlier, the region, the frame, and anything else that we want to pass into coast. So we'll start by setting the region. The region is always set using -r, the common option. And then after -r, you add any arguments that are passed to that option. And there's a bunch of different ways that you can specify a region using -r. In this example, we're going to use the ISO code. And this is really useful for instances in which you want to plot a country or a state that you don't necessarily know the geographic boundaries for, as is the case for me right now with Italy. So I'll use the 2-digit ISO code for Italy, IT. And if you don't know these either offhand, you can look at the Wikipedia page or other resources to find these online. So now we have our region set using the -r common options. We also want to set the frame. And as we learned earlier, that's set with -b. And just setting -b without any options, we'll use some GMT automatic settings. We're going to leave off projection for now and see what GMT chooses as a default option. But we do want to color the land, and we do that with the -G option. And this is the first option that we've seen that isn't a common option. So this is not universal across all the GMT modules. We need to specify a color using -G, and there's many different words associated with colors through GMT. There's from the GMT homepage, you can see a list of this. There must be hundreds. And so we'll just use a simple green. So now we have our first super basic GMT script to create a map of Italy with a basic frame and land colored green. So I'm going to run this down here in my terminal, type bash italy.sh using tab completion like you saw from Paul earlier. There wasn't anything printed in SD out, which a good sign means that it likely worked in this case. You can also see over here, there's a new file, italy.png, and we can see that this created a pretty okay map, but there's some improvements we can make here. In particular, I personally find this a pretty awful color of green. So let's go back and try to change that up. So in doing that, we can change green to one of the other GMT supported colors. We'll make this wheat. And this process of writing a GMT script, viewing the output, revising according to your observations is pretty standard. So making maps in GMT is a very iterative process and something you'll probably do many times before making your final figure. So let's see how these revisions look. We can go over to the PNG and it's starting to look a bit better. It would be easier to see the difference between the land and the ocean if we had a pen outlining the land. So let's go back to this shell script and add a pen. We'll do that using -W, which is not common, but is used for many GMT modules to specify a pen type, and we'll call this thin. And that will have GMT use a default color of black, but a thin pen width. So let's make this one more time. Now it's starting to look a bit better. I don't think that this is the best projection for this map. So I want to add a projection specification back to my script. So to add a projection, use the -J common option. And then we append or in most cases, one character letter that specifies what projection we'll be using. So for this first, we'll use one of the most widely used and widely abused projections, Mercator, which is specified with M. And in GMT, you can use capital M to say that you're going to append the width of the figure. So we'll append the width, that's 15 centimeters. If you had used a lowercase m, you would be expected to instead provide the scale of the figure. So now let's look at the difference now that we've specified a projection using this -JM. So you can see that it's changed quite a bit. Now it's a bit more vertically elongated. And it's looking pretty nice. It's hard to tell exactly, as someone who has never been to Italy, exactly where Italy ends and the other countries begin. So let's try to draw some country borders so that we can see exactly what the boundaries are for the various countries that are shown in this plot. And we can do that with the -N option. This is, again, a non-common option, so it's not universal across the different GMT modules. You can look at the GMT documentation for all the different additions that can be made using -N, but we'll add 1 after it to specify that we're going to draw country borders, and then we'll specify a pen using thick red. So now we have the country outlines, and we can see that map ends right at the edges of Italy on any side. And we can add some space around this to show a better context for the country by adding a modifier to the -r common option. So again, -r common option sets the region. Modifiers in GMT refer to anything that's appended to these options that looks like plus a letter or plus a letter and then additional text. That's what we call a modifier, and it modifies the behavior of that option. So we do plus R2, which will round the region to extend it a little bit past Italy. So now you can see that there's a little bit more boundaries separating Italy from the edges of the plot on any given size. As we saw in, or as I mentioned earlier, there's a bunch of different ways to specify regions. So say I want it a little bit closer on the southern border and a little bit further towards the west. So I'll say I want something from about 5 degrees longitude to 20 and say 35 to 48. So I can go back here, and rather than having this specifier for the -r common options, I can write in the minimum longitude and then a / and then the maximum longitude and then / the minimum latitude and the maximum latitude. And so this gives a bit more control over what the exact boundaries of the map are. So now we can see that the frame or the map region has changed a bit. And this is looking good. I think there's just a little bit, so it might be a little bit hard to highlight exactly what country you're trying to show here, given that they all look the same. So let's color in Italy, and we go back to our script, and it's GMT, so there's an option for this. We can use the -E option and then append the ISO code. And then we need to use a modifier plus G to specify the color, and we'll say it's going to be red. So now we have a nice map showing the country borders for Italy and the surrounding countries. Italy's colored in red. There's a coast pen outline in a black thin pen, and the land is colored in wheat. So I'll just show you 2 more things before we wrap up this first how to make a map in GMT and move on to how to make a few different figures or subplots. So first, we'll just show how in particular you can save multiple figures. So say you like this final plot and you need PNG for one presentation, but a PDF to send to someone else. You can list multiple formats here. So we have PNG, PDF, which will save a PNG file and a PDF. Now, if I run the script, I see 2 files here, both a PNG and a PDF. We'll also show the basic structure for how you would make an inset map. So within a GMT session, you can have different modes. You can have a figure, a subplot, or an inset among others. So for an inset, you do GMT inset begin, and then GMT inset end. And within these 2 commands, you have your code for creating an inset plot. So GMT coast, and then specify your projection, your region, your frame, and what you want colored, say land or ocean. And then it will create an inset map that will show some context to your full map. So since this code is pseudocode and it won't actually work because we didn't add any options to inset that specifies how it should draw the inset map, or to coast to specify what coastlines or other aspects you want plotted. We'll comment this out. So here we've created our first GMT map of Italy using the GMT coast command. Oftentimes you'll have one of these scripts that just creates a single plot or a single data processing step. But sometimes you'll want to have a single GMT session, which is wrapped by begin and end, that creates multiple figures. So now we'll go over how to do that using GMT. So I'll go back to getting started and create a new file where we'll make our multiple figures in a single GMT session. And I'll save this. We'll make some world maps. So I'll save this as world.sh. At the beginning of this file, like all others in this workshop, we'll want our specifier that it's a bash script. So the same as always up here at the top. And then comment to denote what exactly is being done in the script. So we'll make 2 figures in 1 GMT session. So the basic structure is just like before, with a GMT begin and a GMT end, and optionally the show. And then to start with, we can add the prefix and the file name. We'll call this world and a PNG file. We'll use coast again to make our map, so GMT coast. But this time we want to make a global map. So we'll use -R to specify the region, but rather than having an ISO code or a min and max longitude and latitude, we'll use one of the GMT shortcuts, and that's lowercase g, which tells GMT to plot the whole globe. We'll need a projection, and in the GMT cookbook, you can see the different projections that are useful for plotting an entire globe. We'll use the hammer projection here. All of these global projection options are pretty similar for what they expect after you provide the projection. You'll have to provide a central meridian, which we'll do as 0. And then you'll have to provide a width. So we'll say it's going to be 15 centimeters wide. We also want a frame. Here we'll add G to plot some grid lines without any other information. It'll just plot what it thinks default grid line should be. And lastly, we'll want to color the land, and we can color the land purple here. So this will create a world PNG file using this coast command where we have a global map with a hammer projection, basic frame with grid lines, and purple land. I'll run this. Now we have a new file here, and you can see it is beautiful, but we want another one too in the same session because it's going to have related plotting. So we'll add GMT figure to specify which code goes to which figure, and then we'll name this world 1 and PNG. Since we have the prefix and the file format here, we don't need it up at GMT begin anymore. I typically use indentation to show what code is associated with what figure. This is just a style preference. It's not required like in Python. So we can run this now, and we see that there's now a world 1 file that has the same output because we use the same GMT coast command. To create a new file or a new figure within the same session, we can add another GMT figure command. So we'll call this one world 2 and a PNG file. We can make a similar map with coast and -RG for global, but let's use a different projection so we can see the differences. So here we can use a Winkle projection, which is -J capital R, same central meridian, same size, and the same frame characteristics, but let's make it a different color. Let's make it orange. So now we have world 1 and world 2. So you can go back and forth between different figures using GMT figure, but generally it's a bit more readable if you stick to having all the code associated with a given figure under a given GMT figure call. So now that we've created multiple figures within a different session, we can look into how to create multiple subplots within a given figure. So let's start afresh in a new file for these subplots. This is one step you won't be able to see, but I'm just saving this file as worlds.sh. And again, we just add this first line that specifies it should be interpreted as a bash script. And we'll set up the basics for our GMT session. So our GMT begin call and a GMT end call. We'll name this figure worlds.png. And then inside this session, we need to specify that we're going to be creating subplots. And we can do this using the GMT subplot module. And there's various modes for a subplot. To start a subplot, we want to have GMT subplot begin. And then we need to specify a few things. First of all, we need to specify the layout of the subplot. So we'll say it's going to be 3 rows and 1 column. We also need to specify the size, and this is done using the -f option. And there's a few different choices you can make. You can specify the size of individual subplots or the size of the figure. We'll specify the size of the figure using F, and then we'll say it's going to be 16 centimeters wide and 25 centimeters tall. And then in order to label the subplots, we'll use this -a option, which just adds A, B, C sublabels to each subplot. After we finish the subplots, we need to tell GMT that they're done. So we'll put at the end a GMT end. Within this subplot begin and subplot end, we can make our given subplots. So each one of these will be a global map that we create using coast. So just like we've seen a few times before, we'll have GMT coast -RG for global. For the first plot, let's use hammer again. So with a 0° central meridian. And we need to specify the size of the figure, but we don't necessarily know what that needs to be because we have region and final figure size. So this is a special GMT thing where for subplots, when you don't necessarily know what the size needs to be, you can instead use this question mark, which tells GMT that it should automatically create the size of the subplot based on the size of the figure and the region. We'll add a similar frame and we'll plot land. And in this one, we'll use a different method for specifying the color of the land. Rather than providing a word that's associated with the color in GMT, we'll provide a RGB triplet. So let's do 35 red, 100 green, and 88 blue. So this first command, without any additional information, will be automatically plotted in the first subplot. Then we can add code to go into the second subplot, and we want this to be a similar world map. So the first set of options will be the same. We'll call the coast module the GMT program. And well, let's use the Winkle projection again. So JR 0 and question mark again to specify an automatic size, and simple grid lines, and then gotta have purple in each one. So we'll have purple land. And now we need to tell GMT that it should plot this command on the next subplot. So that's with the minus lowercase c common option, which tells GMT to move to the next subplot. And let's add one last command for our third subplot. So we have GMT coast, same global region, new projection. We can use the Mulweed projection minus JW, same central meridian, same automatic sizing, and similar frame, but let's make this light gray. And then for this one, we're also going to plot water as a color. So let's use minus S option to plot to color in the water, and we'll make the water light blue. And once again, we have to specify that we'll be moving on to the next subplot. So this tells GMT that this coast command is going to be output to the next subplot. And now we can run this script and see what happens. So we have a new PNG file that has 3 different subplot panels with different projections and different coloring of the land and water for the last subplot. So now we have some examples for how to create both individual figures within a GMT session, multiple figures within a GMT session, and some subplots. And so we're gonna jump into our breakout rooms and try out modifying these scripts to make a few different plots. And for the first exercise, we want you to modify the italy.sh file to plot a map of your home country. And if you happen to be from Italy, you can plot a country of your choosing. And in the second exercise, you should modify
9:55 on my clock. So that should be 19:55 UTC. So
Yes.
once
Yes,
Joachim
it is.
finishes his snack, he can take it away.
Peach. Okay, so shall I start?
Yeah, sure. Yeah, whenever you're ready.
Okay, so I'll share my entire screen because I will be swapping between different feeds. Okay. At the beginning, Leo posted a link in chat from the GitHub site. I had years before I had, but no point. I don't have sliders to show because the figures are visible. That's what you are seeing on my screen right now. It's if you go to the GitHub site of the course and select the line symbol directory, it has a README with the figures. So these are the things that we'll be doing. And there are links to the scripts that do all of them because it's very possible that I won't have time to go through all of them. So, and that's what we are going to do here. So we're going to start with lines, how to draw lines and different types of lines, then symbols, and then polygons and filling polygons. Part of this was already shown. Megan already draw lines to do the outlines of the countries or plotted color lines. So it's a bit of that and continue. So to start with, we're going to replicate this this image. Oh, and what's this? Not this one. This one. And another thing is on Windows, I can set the terminal on Visual Studio Code on Windows to be Git Bash, but it gave me some strange errors not recognizing names in modern mode. So I'll do it in a classical way, and you do it the same way you did before for the scripts that you ran before when I can show you the examples. Not these. Esteban asked it in the chat, so already I recommend that to some Windows people. On Windows, if you have a directory where you have your data and you want to start and you have installed the Git bash, you can just select Git bash, not GUI, the bash here. And well, the only advantage that it will start right away on the directory where you have the data instead of having to change directory. Because changing directory, you have, even if you are on Windows, you have to use the forward slashes or otherwise double backward slashes. And so if people on Windows are used to do these, CD, 2 points like this, they will have a surprise. No, it did work something other. Should have been the other way. Okay. Just losing time. So
sorry to interrupt, Joachim. Do you mind cutting your video? I'm having some trouble hearing, and I think maybe not showing video will help.
Oh, maybe yes. During classes, I had that thing with the strange. We have problems with the sound. Yes. Sometimes the sound is not.
Yeah, it could be better now. Let's try it out.
No, wait. I'm not yet. Where is that thing? Stop it. Okay, right. So we'll start by doing that straight line, a red line, and we'll start. I will copy paste some of these because honestly, I don't remember all of these to type. I know it's not such a good for examples, but I'll start with this simple example where you have the usual way of starting the mother mode, GMT begin, the name of the file that will be lines. And for example, to use it as an example, I'm not going to use files that you have to download or something. We just generate 2 endpoints of straight lines and use them. That's what these 2 lines do. So we'll talk about that. In the beginning, if you do echo, there will be a line that starts at coordinates 0, 0, and will end at coordinates 10, 1. And they will create a temporary file that here the short names called t.dat. And that's the coordinates of the file that we're going to use. And then we're going to use it here in the GMT plot command. The GMT plot command was previously known as PSXY for the people that come from the older time. And as I explained also in the chat when people ask me, modern mode dropped the PS from the model names, except plot and plot 3 that changed PSXY and PSXYZ to these names. So, and because this is an example, I define a small rectangular region that goes from -1 to 11, -1 to 11, and use a linear projection, because this is not a map projection, it's just XY, an XY file. But I can even drop this thing and leave the automatic. And you're going to draw lines with plot. The option is -W. It's not always -W drawing lines. For example, when Megan showed the country borders, she Coast uses -N to do that. So -W is not a global option, but the arguments when you are defining a pen are the same if they are used with -W or any other that plots a pen. So a pen is something that is defined by the thickness, the color, and the style. But we don't have to specify them all. If you just specify the first argument, a number is the thickness. If you want to add the color, we add the color name, or we can add the color by defining their components. So if I save these and run it, one is so bash lines will show just this though. Nothing really exciting. And if you want now add a line that is dashed, I think is the next one in thicker. If I want to make it thicker, I will add more lines to build this image. I could replace the command, but I will just keeping adding more. Oh, better to close it for also. The same mistake. That. So next one, I'll copy it already. It's blank. Lines. Because I'm copy passing, I'm going a bit faster than you do. But you can also just copy the others and see that it doesn't change almost nothing, just the coordinates, because I don't want to overwrite the line that on the example before. So the next line, we are going to draw a thick green line. Thick, well, could be thicker. So it's the example with, okay. And we don't need to repeat the projection and the region anymore. So now it's shorter, just different coordinates. And this time, we have the explicit the units here, and we'll draw a thick with 3-point thick line. On the same, continuing, I can add another one, 0, 2, 0, 3. And this one will be like the previous one, but dashed line. So in this later case, we have the example of the three parameters, the attributes that define a line: the thickness, the color, and the style. If we do not say, don't specify neither the color nor the style, what we get is a black line. And even the thickness is by default 0.25, I think, points. So even the thickness has a default value, which I think is a bit too thin. But even the thickness, if you just specify -w, would draw a line with the default thickness. So, but if I add the three attributes, thickness, color, and style, and I run it. By the way, you can, well, most of you know that for sure. You can use the up and down arrows to repeat the previous command. And here we have it. Continuous, also continuous in thicker, and the dashed line. The lines can be dashed, dotted, dash dotted, and, well, this is the simple ones. And then up on top of that, we can also define our own patterns. And the patterns is saying the length of the dash, the length of the gap, the number of times it repeats. So it can become, it becomes, well, powerful, but also can become a bit more complicated. The simples is just that. You have dash, dot, dash, and dash, dot. It's what the next examples show. So yeah, I'm going to copy a couple more. And two, not one of them. So now we have next a dotted line, black, and we say instead of dashed, we say dotted, and only thing that changes is the coordinates. Again, to move it a bit up on the stack of lines in the figure. So we have again a line with a thickness of 1, it is black, and it's dotted. And you can do a dash dotted. We can use either words, dash and dot, dash it and dot it, I think dash and dot as well, or we can use symbols. This example here is a dash dot. How do we do the dash dot? With a dash or minus and the dot in symbols. So this would be equivalent of saying dash dot, I think. Again, well, maybe a little bit longer, so you can. The copy paste is from the previous lines is simple, but well, if you don't put the coordinates correct, it's no problem. It's just we'll show it in another place in the demo figure. It's no problem at all. Okay. So again, I run and nothing. What happened? What did I do wrong?
Didn't save the file.
Didn't save the file. Yes, the dot. Yes, that happened to me so many times. See, that white circle is warning me. And yeah, here it is. So dotted dash dot the color. Well, let's try if we do it instead of no. Let's write dash dot dash it. Dot. I'm not sure about this one. Dash dot. I'm not sure about this one. So if it does not. No, it did work. And I think it accepts dashes and dash and dotted and dot. So we can either spell it in words or use a shorter version, like in MATLAB for plotting lines. Use the dash and the. With these, you can already do a lot of things, a lot of different lines. If you need to plot XY figure where you have many lines and want to distinguish them between one and the ones and the others, this is one way, using color and using line style. I do not have it here. Well, didn't think on that because we have an auto legend that when you do like this, you normally want to have a legend in the figure saying what each different line represents. Well, should have thought on that, but no, I didn't. Well, further than these type of lines, there are another family of lines, which are the annotated and quoted lines. Annotated lines is, for example, like when you have a contour and the lines have a label of the ISO value of that contour. This is an annotated value that is annotated line that is done automatically by the program. In this case, for example, GRD contour. But we can also do annotated lines in our XY plots. The syntax starts to be a bit more cryptic because you have to use the -s for the symbol. No, I jump in one, sorry. I'm going to do both of them. But since I started talking, you select a symbol which is an annotated line, and that Q means annotated line, and then the number of annotations, and then the font, and then what you want to put. So it is powerful, but it also starts to be a bit more cryptic when you see it just the first time. So this is when you have to go to the manual, read the description, it's well described, but because you can do so many things, you can select the spacing between the labels, the fonts, everything, the gaps. So there's a large control, and to provide that large control, you have to pay it in different options. And when you see the description, the first times can be a bit more scary. But let's see it. If can you see, I can increase a little bit the font because that ones are easy to type. This one. So what will this do? It will plot a line with 15 tile symbols along the line. It's annotated with a single letter. You can annotate it with a sentence. You can annotate it with what you want. And there are also the quoted lines that you can put many different symbols along the lines. The syntax of the program is similar to this one. And it will be a line with a thickness of 1 and the color sienna. If I say it's saved again. Again. Oh, see? Now I have a different type of annotations. And if instead of a tile, I put something else, I will get something else. I'll do it very quickly. Again, I just go here, and if I put the @ symbol, just change that one. See, now probably another thing is the symbol is too big for that number that was plotted in line, so it should have selected a lower number of symbols so they do not almost overlap. Okay, I jumped it a bit when in the previous one. If you notice this line before the annotated line, you see that it's thicker. You see that the dashes are not sharp cutted; they are rounded, and that is obtained by a parameter that you can use when you're plotting lines. If you select this option that is called PS line cap round, you make that effect to the lines. Of course, if we have a line that is thin, we don't see the effect of this, so no bother to use it. But when we have thick lines, you can see the effect, and you can see it so much that you can even make a line looking like a circle. And then I'll stop. This next example, we'll use the line cap. Oh, sorry. Yeah. They will use the line cap round, and because it's drawing a line that is quite thick, 10 points of thickness, and it will be orange, and separated by a gap of 20. Remember, we are drawing a line, but what we see I know. That's what I think. I thought someone asked it. Yeah, maybe was not this that happened to someone that was asking that in the Slack. The issue is this. Since very recently, I think, at least I start to see it after a Windows update. If I have a file, an image open, I cannot regenerate it because I get this error. I have to close it first. It didn't used to happen, but now I'm getting that many times. So this error means that the Ghost script wanted to convert, and it could not update the other file because it was open, and there was a hole to the handler from the system, and the image could not be updated. It's nothing that is not our fault. If you see that, I start seeing this recently, what we have to do is to close the previous figure first, because it has the same name, and run it again. It's very boring. It's annoying, this thing. But no, what can be done? So you see, this looks like we are drawing circles, but in fact, what we are drawing is a line, a dashed line that is rounded, and each half of the round end touch the other one, such we get a perfect circle. So we can do circles like these, and the other example that is on the page, I will not reproduce it. You can even alternate between one size and the other, one color and the other. So see, you can use all of these to draw lines whenever we need to draw lines, either on XY plots or doing maps, and you need to draw lines in a map, and you need to distinguish between one or the others. You have all of these options to make our lines distinct from each other. And there was lines, and now quickly to symbols. Symbols are similar to lines, except of course you have a position for each one. So, 19, oh, my time is short. I start a new file. Save it. Yeah. Symbols. SH. And here I'm showing another thing. I think it was not shown before today. Well, the plot symbol needs the coordinates of the symbols that we want to plot. You can plot just one, like is this example, or we can plot 1,000,000 points. If we wanted to plot 1,000,000 points, you will need to have a file with the coordinates of all of those points. Here for demonstration, instead of having a file, we will provide the coordinates of each symbol. And we can do that by piping the coordinates through the program. So we don't need to have a file. This means that we will pipe the coordinates 0, 0 to the plot program that will be plot a figure with coordinates between -1 and 6, a square, make a rectangular area, and I need to go this. We'll add a title, and we'll only annotate the left and the south, or the left and the bottom axis, and the other ones we'll just draw them but not annotate them. And we'll add a title and still add a grid line to the plots, and we'll paint it in green, and it will be a circle. Yeah, we select the symbols with the -S option that has lots of symbols. Most of them start with the letter, the character of the name. C means circle, not all the times. For example, a star use an A, not S, because an S is a square. So not all of them can be addressed with the initial of the word. And we'll make it the size of 0.75 centimeters. Well, at the same, we'll have this example. We are plotting one symbol, just the field, the color. But we can have symbols, and we want the outline of the symbols. Symbols do not need to have be very teeny. You can have big symbols, and you might want to have a symbol with an outline. An outline is just a pen. So again, this is what we saw before. Defining the pen is an outline with a thickness of 1 will be black. The next line will be a thickness of 1 with a color defined by 0 red, 130 of green, and 0 of blue, the same size. And the next one will have a dashed line. So this is almost the same as we saw before. The file name is different, symbols. This. Oh, see, we plotted 4. One has no outline. The next one has a black outline. The third one has a green outline. The fourth one has an outline that is dashed, and so forth. So I'm not going to repeat all of these. You have the script with all the example with the commands that allow you to plot these ones. And the first row is just changing the pen type, and the second row is how to select different symbols. This is more or less it. But GMT has also another type of symbols which are called the custom symbols. Custom symbols, GMT comes with a collection of custom symbols and also with a language that allows us to create our own custom symbols. I'm not going through that. even, because when I want to use it, I have to read the manual several times because it's a language that you have to draw your own symbols. But these ones are they come with the GMT, so we can use them right away. Just close my figures. I'll reproduce here one or two of these examples. Symbols. So custom symbols are used with the -s option again because it's a symbol, and then with the K. K is what stands for the custom symbol, and then you just specify the name of the symbols. You have to use the right name, otherwise you will call a symbol that does not exist, and you will get an error. The manuals have the list of the symbols and the names of the symbols that we can use, and you add the size of the symbol also, and an outline of that symbol that we want. So it will be similar, just plot it a bit higher on the plot the fill, the color of the symbol, the outline, the thickness of the outline, the name of the symbol, and the size. And if you run these, coordinates that change left to right. If you run these, where is that one? See, we get the symbols, all of the symbols. So we can make them the size that we want, and they are about 20 or something. Simple symbols that have simple shapes that predefine it, and we can use them instead of circles or stars or dots. Make our plots and connected. They can be connected with lines, with all the line types that we want. So you can mix all of these together to make crazy or complicated lines and symbols that we want. To finish these, there is still one more way of doing symbols. And I will show, where is it? Is that besides what comes with GMT, we can also use PostScript, EPS, in fact, images to work as symbols. So what you see here, the rooster and the sardine, are files, EPS files that we can access from the GMT server. They are there, and we can make plots with any image that we want, in fact. So instead of having the classical symbols, the custom symbols that are forms, we can make plots with any symbol that we want, as long as we have a PostScript file, an EPS file, that it has to be a little bit worked because we don't want to have a file that has a lot of white space around, so that we're going to waste in the figure. And how we call them? I just do the rooster. So this example shows you how you call those images. The file exists on the GMT server and is called galo.eps. You don't put the extension, you just put the name. And when you put the @ symbol before a file, it means that if the GMT server have that file stored, it will download us for us. And then you will save it in our computer, and next time you will use the one that was previously saved. Leo is going to talk much more about this after, because it's not only these simple files that are available. You have a whole collection of images and grids of different resolution, all that you access by the same mechanism. By putting a @ symbol before the name, GMT will download the file the first time for us to use. So for the test, for demonstration, those files exist there, so I can just address them by the name, and it will work because it knows what this name is. If you type with just name of a file that does not exist, we will get, not surprisingly, the corresponding error. If I do it, Here we have the roster that could make different sizes again. So this is about symbols. Just one. I told you can use anything we want. If instead of the symbols we have a raster image, this one is a JPEG image of a tiles that we use in Portugal for the houses. You can replicate that image inside the symbol what you want. So you can use any image. In fact, you can use any image that you want to fill our symbols, to fill our forms. This flower is in fact a polygon that is filled with an image that I have in my computer. Now we have that image, in fact, in the tests. So it could be done with I think with a hat call or something, because we use this small image in our data set. So you can draw with these, you can fill the symbols the way you want. And the symbols, I don't know, I'm in time. Paul, how much time? No, it's not. And finally, okay, Italy is very. Sorry, Paul. How much?
I'll get back to you on that.
Okay, no problem. I'll continue. So Italy is because of its shape, is a very popular example that we pick from. So this one will show you how to fill with polygons. A polygon is a line, is a polyline that is closed. Means the last point and the first and last point are the same. And when it's a closed, or when we tell it to close, we can fill it with patterns. This example shows a bit like before with the example with the flower. We'll use patterns to fill the polygon. And to have this polygon, okay, not this one. This one. I will start a new image.
Joachim, you have 15 minutes left of the session before the break. So if you want people to practice, you kind of
15, yeah. Okay. Yeah.
Before they wrap up.
On do not clash with the Italia that we already have from Megan. So this line here again is a bit creepy because we are using the same thing. Oh, it's PS closed. Yeah. The same command, a very close command that Megan already used when we make a first plot of Italy. So we are using the DCW datasets and we are asking for Italy, but we are using an option -m that means dump the data instead of making a plot. With closed lines, we normally use them to make plots, but we can also use them to dump the data for us to use later in any way that we want. That's how we're going to use this. So this one is saying extract the Italia border, but Italy is not a single polygon. Yes, Sardinia, and there's many little islands and small rocks, and the polygon has many segments. And because of it, I'll do the trick that convert it and only retain polygons that have more than 3,000 points. With this, I assure that I only get one polygon will be a main body of Italy, and we'll save the file in binary form. Well, redirect, and we call it .bin, also indicate that is a binary file. And we do this using an option, the -b means write in binary. So it will be O for output and F for float. It means not double precision, single precision. So we're going to write the polygon of Italy in binary. So you cannot open it in a text editor. You will not see it because it's binary. And when the files start to be larger, binary is the way to go. It's much faster, small. The text files is for small things that you can open, look, and change. When you have larger files, we don't use text files. We use binary files in whatever formats that we have. So no, so there's one. So and after. No. So this is also an example of another thing. The modern mode starts in a script after the GMT begin. Before the GMT begin, you can type other commands. But if they are, probably I should have put it inside. But well, maybe it was not the best example, but it's also show a real thing that we do. Before the GMT begin, anything we type is classic mode. And in classic mode, PS Coast, the program is called PS Coast and not, because this is not a good example. I think I should do this. Now everything will be modern mode. Extract the polygon, create a binary file with the main body of Italy, and then plot it. Because the file is binary, you have to tell GMT how to read it. Because text files are relatively simple, they do not change to read. Binary files, you have the bytes, everything in contiguous in memory, yeah, and you have to tell the programs where one number stops and starts the next one. So here you use again the -b, but here you use it O for output, here is I for input, and there are two columns because it's long lat, and it is a float. So all of that is concentrated in this small option, -b I to f. The limits of the map, the projection mercator, and a pattern. Well, if you see in the GitHub site, there is a link to the patterns, to the GMT patterns. So you have all of these patterns, they have direct and reverse, that we can use to fill our polygons. So this is a list of them, and they are defined, well, they are called by their number. You have to consult this figure to know what you are using. So the use is the number, this case 32. To make it a pattern, you have to put it a lowercase p, and then you have to do the resolution. -r 100 means 100 dpi's. If you go to lower values, the pattern will be larger and coarse. If you smaller values, it's much smaller and more fine. And we can also select the background and the foreground. This one also only selects the foreground. But +F means, +F blue means that the pattern will have a foreground of blue and the default background. I could have added also -b for background and set another color. So again, what does this do? It plots the polygon with a certain projection and fill it with a pattern. And to make it, it's very with the times, we'll use a custom symbol. Mecha is a custom symbol that simulates a mechanism. That's why it's called mecha, or 3 centimeters, and we're gonna add it to the figure. We're gonna plot it at the position 14 longitude, 13 latitude, and use again the echo to send in the data to the plot command. Save. That is equal shell, and let's see. Oh, okay, here we are. So see, the foreground is blue, the background is transparent because we did not set it. We have a line that is a polygon of Italy only, and we add a little football ball to be used for exercises for on the Breakout Room. So now we can, and you can try this, change the patterns, change the foreground, change the background as you want. Well, if you had time, I would say even find an image and do the filling with the image to see what you get. And where is it?
Probably should go to the group exercise, Joachim, because there are only a few minutes left of.
Yeah. I finished. I finished. I just want to make, where is that one? Just finish. Yeah. Okay. Group exercise. Try to do this. I have the field, the grass of the football field for your image. So the group, the exercises are simple. Play with different patterns, different colors of background, and try to add this. Well, and not. What is this? Is just a rectangle, another polygon with another pattern, except that he has to have the coordinates that they are right. Okay, so it's end. Again, the GitHub site has the scripts to do this, except this last green stripe that I added today of what I added before, and this one too, but it's many things. So, I finished.
Okay. So we'll try to do the group exercise. So Megan, so Melissa, please send us into the breakout groups. Time marches forward. Time marches forward relentlessly, Leo. It's not much we can do about slowing it down, apparently.
Yeah. Yeah, I can't believe it's been over a year of homework.
That's right. It's important. Very good. Well, I guess it is 11 o'clock my time, which is 2100 or something in UTC. So you're up whenever you want to start.
All right. Okay. So yeah, welcome back, everyone. Hopefully you're all still with us and managed to take a little break. And so I'm gonna share my screen here. Okay, first of all, apologies. I'm not going to be using Visual Studio Code because it decided to start crashing on me today. So we'll go back to good old VI and the terminal. Okay, so for this section, we're going to be looking at how to plot grids and images, mostly grids at this point. So we're going to be making contour plots and also these pseudo-color plots, like the one shown here. All right, so for GMT, the main grid format that we use is called netcdf. So netcdf is a self-describing machine-independent data format. So it supports the creation, access, and sharing of array-oriented scientific data. This basically means that it stores the gridded information in a binary format, including the values, coordinates, metadata about what generated the grid, what the coordinate systems are, and so on. So it's a very, very popular format. It's widely used, particularly in climate and atmospheric sciences, but also for distributing things like DEMs and a bunch of other gridded data sets. So this is kind of the gold standard for that. Okay, so there's further reading about the file formats and so on in a link here to the GMT docs. Right, so I try to sprinkle these into these notes so that there's always some further reading for you to do. Okay, so following along, we're going to be looking at several GMT commands. All the ones that deal with gridded data start with the letters GRD. So if you see GRD image, GRD sample, GRD contour, and so on, you can already tell that they're going to input, you're going to have to input gridded data to that module, right? And that's usually going to be a netcdf grid. So throughout this section, we're going to be using some built-in data from GMT, some earth relief grids. So if I open up this link here, so this is showing us what are the earth relief grids that GMT offers. So in our servers, we have a whole bunch of different grids in various resolutions of Earth relief, all the way from 1 degree resolution all the way down to 1 arcsecond resolution that's served in several tiles, right? So you don't have to download 41 gigabytes of images just to plot a little section. So we're going to be using some of these, and Joachim touched on that with the @file names, and we're going to be using that a little bit more here. Okay, so to start us off, the first command, the first module that we're going to look at is called GRD info. And as you can expect from the name, it's going to give you information about a particular grid file. All right, so I'm going to hop on here to my terminal. So pretend that this is the little terminal on the bottom of Visual Studio Code. Okay, so I'm going to type here the command GMT space GRD info space @earth relief and underscore 10M. And the 10M here stands for 10 arc minute resolution, right? So when I ask for this, GMT is gonna download, it's gonna download the Earth relief 10-minute resolution grid if I don't have it already. And if you already have it, instead of downloading it, it's just gonna find it on your computer and load it. So for me, this particular grid is stored in my home folder under the .gmt server earth relief 10 MP GRD file. So this is where the file lives on my computer. And the information that GMT can get from that is the title, which is Earth relief at 10 arc minute resolution. There's the command that was used to generate this file. So this file was generated by the following GMT command, right? So we have here a GMT GRD filter of the SRTM 15 plus version 2.1 grid with several filtering arguments for downsampling. Right, so this is a nice part about the netcdf allowing metadata is that we can actually tell, we can include in the file the command that generates it, right? Which is a very handy feature. There's some remarks about where this data came from. So there's a reference to the full publication. It's saying something about this being pixel node registration, which we'll touch upon later. The grid file format. So it's saying that this is a GMT netcdf grid in 16-bit integer format following the CF conventions 1.7, which is a set of conventions around the metadata. It also gives you the boundaries of the grid, so the minimum and maximum in the X dimension and the spacing, right? So this is minus 180 to 180 longitude with a spacing of 0.1666 yada yada degrees. Same thing for latitude. Same thing for a scale factor here that's used to scale the data from integers to floats. And also some more information about the formats and compression and all that. Right, so with GRD info, we can tell a whole bunch about a data set by just looking at the single file. Alternatively, we could say GMT GRD info at Earth relief 10M. And if I say minus uppercase C, lowercase n, GMT is going to print out just the numerical information. So the bounding region, so west, east, south, north, and a minimum and maximum, and the increments and so on. So it's a bunch of information that GMT prints out that you can actually get this using some shell scripting. Say, for example, if you want this information to set the region, or if you want this information to get the grid spacing or something like that, you can do that easily with GRD info minus CN and then some scripting. All right, so this is a pretty common module to run with the minus CN if you're doing anything with gridded data or any kind of processing. All right, also sprinkled throughout my notes, there are some bonus content which you can go back and read this a little bit later, usually followed by some links. Okay, so now that we've covered the Earth relief data sets, there are actually a bunch more in our remote data sets. So I would urge you to go and have a look. And anytime you go into the documentation and there's a file name that's at something, that means that it's a data set that lives on the GMT server. And if you don't have it on your computer, GMT will automatically download it for you. Right, so you don't have to worry about downloading these files manually, which makes it so that most examples in our documentation, if not all of them, you can copy and paste to a script or a terminal, and they should run even if you don't have the data, because GMT will take care of that for you. Right, the Earth relief data in particular are extremely handy. I use them all the time as well. We also have the global seafloor age by Miller et al. So this is also a pretty handy one, and it's available in multiple resolutions. We have this global Earth day and night image that's available as well that you can download, and a bunch more that we're thinking of including as well. Right, so there's a lot of stuff that you can get from our remote data sets, and this is a feature that we're particularly excited to expand upon in the future. Okay, so finally, let's get to some plotting already, right? So what we're gonna try to do first is make some contour plots of these Earth relief data sets, right? So the first plot we're gonna try to make is this contour plot of Antarctica topography and bathymetry. We're going with Antarctica here to avoid being biased towards any particular country and making some people angry, of course. Okay, so where's my terminal? Here we go. So I'm gonna jump here on my text editor. So pretend that this is a new file on Visual Studio Code. And we're gonna start making a script that makes that plot of Antarctica. All right, so the first thing we do whenever we start a GMT script is to say hash !USR/bin/env and space bash, so that we know that this is a bash script. And then we're going to start, as always, with GMT begin, and let's give it a name. So let's call this Antarctica. And let's say that the file format I want to generate for the plot is a PNG. Okay. All right, so now that I have my GMT begin, I can do GMT end. And let's put a show in here so that the plot pops up. All right, so the first command I want to run is, let's say, GMT basemap. And what basemap does is it plots basically the map border. All right, so this is a useful command to run if you want to set the border. You can also include most of these options into other commands. But I usually find it easier to have it separate with a call to basemap. So in here, we're going to set the region. And since we're plotting Antarctica, the country code for Antarctica is AQ. Then let's set a projection with -J. And for this one, I'm going to do a stereographic projection, so uppercase S. And let's set it centered on the South Pole. So 0 longitude / -90 latitude. And let's make this a 15 centimeter wide map, right? So 15C. Then I'm going to ask for automatic frames. So I'm going to do -B. And GMT will, by default, draw the frame and put some tick labels. Oh, sorry, no tick labels, just the frame. Okay. Then what I want to do now is plot a contour of this grid. So if you were to guess at a name for this command, it would be GRD, since I'm inputting a grid. And what I want to do is plot contours. So GRD contour. All right. So now that I have GRD contour, I need to tell it what grid I'm plotting. And I'm going to use our remote file for the Earth relief grid. So it's at, so it's going to be at earth underscore relief underscore 10M. And let's just leave it at that. And let's do our default plot to see what happens. So I'm going to save this as Antarctica.sh. And I had a typo there. Okay. And now I'm going to go into my terminal here. Let me clear this. So I have Antarctica.sh. Let me remove the other one. Okay, so ls again. So now I have Antarctica.sh, and I'm going to run this script with bash Antarctica.sh. So let's run this. And then I get a nice contour plot of Antarctica. You can barely see it if you already know what you're looking for, but there's the kind of outline here. Here we have the Antarctica Peninsula. We have the big ice sheet here in the middle that's very high, so 3,000, 4,000 meters. But notice that the default gives you something, but it tends to be very noisy. So with GMT, we always try to give you a sensible default, but that's not always possible to do. So there's usually some tweaking that's going to be involved, right? So, but if you just want to have a quick look at the data, the defaults are usually good enough. Okay, so also, as always, if you have any questions or so, feel free to pop them in the Slack chat, and I'll keep an eye on that. So if it's anything, I can try to address it as well live here. Okay, so I'm gonna close this. And okay, so now let's try to make this plot a little bit better, right? So the one thing that I want to do is get rid of all those little tiny noises in the contours. So like very tiny little features in the contours, I kind of want to get rid of those. So one thing to do that is with the -q, so uppercase Q argument to GRD contour. And this specifies a minimum length of the contour so that it's plotted. So if we say -q and then let's say 100K, what this is going to do is only plot contours that are more than 100 kilometers in length. So any little loop in the contours is going to be omitted. So let's save this and let's give it a shot, right? So I'm going to run my script again. And still quite a bit noisy, so let's make it a little bit bigger, right? And again, with the theme of, try it, and if it doesn't look great, then try it again. So let's say 1,000 kilometers, and let's see what that looks like. Oh, am I running the wrong script? Yeah, I'm running the wrong script. Sorry. And that's why nothing's changing. Yeah. Antarctica.sh. Yeah, sorry about that. So -q, 100K. Let's go back to 100K. Let's see what happens. Bash Antarctica.sh. Make sure I can spell correctly first, and things seem good. So let's go. Okay, so a little bit cleaner. So some of the little tiny loops in the contours are gone, but we probably want to go a little bit further. So let's say 1,000 kilometers as the minimum length of the contours. So I'm going to run this again. And now it's a lot cleaner. A lot of the little specks are gone. And there are several other options that you can use to try to smooth out the contours and so on. Another thing we're going to do is maybe have a little bit less contours plotted here. So let's just change the interval between the contours. So we're going to do that with the -C and -A options. So with -C, what we're doing is setting the interval for the filled so for the contours without annotations. right? So there are two types of contours, those that have annotations and those that don't have. So if we say, let's do every 1,000 meters, let's have a contour without annotations. And then with -a, we set the interval for the annotated contours, so the ones that have the number. So let's say we only want annotated contours every 2,000 meters. So let's save this and run again. So if I run bash Antarctica, now I have many fewer contours. So I'm going to have annotated contours every 2,000 meters. So I have 0, I have -2,000 plus -4,000 plus 2,000, and no plus 4,000 here anywhere. Right, but then the filled contours, the plain contours without annotations, I have them at every 1,000 meters. So another thing we might want to do is control the thickness of the line and the color of the pen and that sort of thing, right? And we're going to do that with the -W attribute. The -W option. So if I say -W lowercase c, this sets the pen for the non-annotated contours. So if I say -WC and then I want the thinnest contours, thinnest line thickness, and I want the contours to be light blue, so comma light blue, then I'm gonna save and run bash Antarctica again. Then notice that the color changed, but only for the non-annotated contours, right? And I can do the same thing for the annotated contours. So as the line starts getting a little bit bigger, you can actually break the line in a bash script by putting a backslash here, right? So if I put a backslash and then hit enter, I can break long lines in a script, which is pretty useful. So let's change the annotated contour line thickness, so -WA, and let's do the thin line line thickness, so it's a little bit thicker, and I'm gonna make these let's say black, right? Or let's leave them black. So, right. So if I run again bash Antarctica, now my annotated contours are a little bit thicker than they were before. All right, so you can play with this and generate any combination of these things that you want. It'll usually depend on what you're trying to plot and the data set, but you're gonna have to do some tweaking to make it look nice. Contours are a little bit tricky because they can be very busy and hard to see. All right, so moving on from contours then, since one of the limitations is that it's very limited what you can actually plot with contours because the plot gets very noisy. So another common type of way to represent gridded data in an image is with a pseudocolor plot, which is where you map data values into a discrete or even a continuous color palette, right? In GMT, this is called a color palette table or a CPT, which is this mapping of values into different colors. In other environments or programming languages, you might see it called a color map, but CPT is a very common thing that you'll read around the GMT documentation. So GMT has many CPTs, and there are several that you can also download from the internet. So there's a list here of all the ones that are built into GMT, and you can go to town here, try to change them and pick one that you like best. So the command for plotting a pseudocolor plot of a grid is grd image. So what we're going to try to do now is make this, so same data set, but we're going to make a pseudocolor plot instead of a contour plot. All right. So to do that, let me make a new file here, and I'm going to call it Antarctica image.sh. And again, I'm starting a new script. So hashtag exclamation dot slash usr slash bin slash env bash GMT begin Antarctica image PNG, right? So same thing as always that we've been doing, GMT end. And I'm actually going to start pretty much the same way. So I'm going to do GMT base map minus RAQ, so setting the region to Antarctica, minus JS for stereographic, 0 / minus 90 to set the center of the projection at the pole, and /15C to make the map 15 centimeters wide, and then minus B for the default borders. Then I'm going to use GRD image to make this plot. So I'm going to do GMT GRD image, and then I'm going to give it the grid file name. So let's say at Earth Relief 10M. Right. And again, just to see what GMT can come up with, we're going to just use the defaults for now. Now, the color image is not very useful unless you have the mapping between colors and values so that you know what each color represents. And the way we input that is with a color bar, which again, we use the GMT color bar module to insert a color bar into our figure. So I'm going to save, and then I'm going to do bash Antarctica image.sh. Oh, sorry, I forgot GMT and show. And run again. Right, so this gives us the image that's on the GitHub. So a fairly standard pseudo-color plot of Earth relief. One really nice thing about GMT is that the CPTs have the concept of a hinge. So it'll automatically put the right color on 0. Most other packages would just put the 0 like at the middle of the range here, which is fairly annoying if you're trying to plot something like topography or gravity magnetic data or anything that has positive and negative. Right, so this is fairly handy. So the defaults, again, give you a very nice looking image and very nice looking plot, but we can do a little bit better. One of the very cool things that GMT has is a very easy way to do hill shading, where you color or where you add artificial shade to the image. So we can do that by for GRD image, we can specify the -I option, which does the hill shading. So if I save and run this again, then if I specify -I with no options, I get the automatic hill shading that GMT can provide. You can also tweak the angle of the light, where it's coming from, the amplitude, and so on, by giving arguments to -I. And I'll let you explore that on your own in a little while. All right, but again, getting a shaded relief image in GMT is fairly simple. All right, so one final thing with the color bar, we can also adjust the placing of the color bar. So we can have it vertically, we can have it horizontally, and so on. All right, so the way we do that is by giving arguments to GMT color bar. So for those of you who are playing around with the inset module, you'll recognize that the -D option, it's very similar to what you get with inset, but it controls the placing of the color bar. So if I do -D and then uppercase J, and let's say MR. So what this means is place it at a reference point that's outside of the figure, hence the uppercase J instead of the lowercase j. And MR stands for middle right. So what we want to do is put the color bar outside of the figure in the middle, or vertically in the middle and to the right of the image. Right, so if I do this and I run my Antarctica image again, I'm going to get the same figure, but my color bar is now on the vertical in the middle instead of horizontal, right? And you can put the color bar basically anywhere you want. Another nice thing that you can configure with the color bar is that -B, so the option that controls the map frame, is also the option that controls the color bar frame. So if you want to set the interval, you can set it with -B. And if you want to add labels to the axes, that's also done with -B. So let's say if I want to add a label to my color bar in the y-axis, I can do -BY, and then I can say to specify that I'm setting the y-axis, and then I can say plus L for label, and then I'm going to start a string. So I'm going to open double quotation marks, and I'm going to say meters and close the quotation marks. So if I save this and run it again, then I'll get a color bar that says meters here on the right. But since I started configuring the color bar, I kind of have to go all the way. So notice that the numbers here are gone now. So what I'm going to do is I'm also going to give it another -B to specify the interval between colors. So let's say every 1,000 meters, put a little, sorry, not between colors, between labels. So if I say -B 1,000, every 1,000 meters, there's going to be a label in the color bar. So here we go. So now we're back. All right, so now I have a nice color bar with a nice even annotation with the zero centered at the exact zero place with meters where it is. So the final thing we're going to try to do is change the color palette table. All right, so the way we do that is with the, oh wait, I just blanked now. I'm going to have to cheat. So everyone has to look at the GMT docs. Like it doesn't matter how experienced you are. I bet even Paul consults the documentation every once in a while.
Oh yeah.
Right. Yeah. Sorry, Paul?
Yes, you definitely do.
Yeah.
Minus C can let
C.
You can pick another name.
Right, -C. Yeah. So I'm gonna do -C gray because I want to see a grayscale image. All right, so let me save and then run this again. Right, so with -C, now I have, instead of the default color palette table for earth relief, I get a nice grayscale image, right? So this is usually pretty nice if you want to make a background or if you're trying to plot something in grayscale for something. Right, so pretty useful to be able to change the color map tables. And I highly encourage you to go and look at the GMT documentation and all the different ones that we offer. And you'll usually want to pick the one that works best for the type of data that you're displaying. Right, so in general, anything that has positive and negative, and you need to highlight the positives from the negatives, you probably want to go for something that is diverging. So it has maybe white at 0 and then goes to blue on one side, red on the other side, or whichever color pair. For topography data, there's particular color maps just for that. For everything else, then you can use whatever suits your purposes. All right, so with that, I think I've talked for long enough. So we're going to go on to a group exercise. So we're going to send you to breakout rooms again. And what I want you to try to do is make a relief map of a country of your choice. Right, so it doesn't have to be your home country. Of course, it can be, but pick a country, try to make a relief map out of it. Right, so use the ISO country code that you've seen so far. You might want to do a little padding on it, as Megan showed that you could do. Choose an appropriate projection. So it could be Mercator, it could be something else. So see what suits your particular latitude and country. Then I want you to make a hill shaded pseudo color plot of the earth relief. So you can use the default CPT, or you can pick another one if you fancy something else. Another thing I want you to try to do is overlay some contours on your plot. right? And the way to do that is to, after you call GRD image, call GRD contour and add some contours to your plot, right? That can help enhance the image, and it can help provide a visual cue for when values change. Then also please add a color bar. As a bonus, add a label to the color bar indicating the units, and also add a title to your plot. And as another bonus, if you want, add an inset with with the location of the country shown. So not a relief map, just showing the location, right? And that'll see if you can exercise most of the things that you saw today. All right. And again, all of this is on the GitHub for this, and Federico already posted a link to that. So if you need a reference, it's all there. All right. And one final thing that I don't think anyone mentioned, if you're looking for the documentation for a particular GMT module, on the terminal, you can type GMT docs and the name of the module. So say GRD contour. And when I run this, GMT is going to open your browser on the page for the manual for that particular module. So if you want to know what all the options do and what all the options are, this is a very handy way to arrive at that. Okay. So
Yeah,
I'll stop sharing here.
That's good. Thanks for catching that, Leo. We all forgot that.
Yeah, I had forgotten as well, but yeah, I
use it all the time
in the breakout room. Yeah, it's super useful, right?
Yes.
I didn't slip it in the moment that I wanted to talk about it. It's as if I had.
All right.
Because you also can open the site. Since you mentioned that, it's not. You can give a little bit more info.
Mm-hmm.
You can do it for the documentation. You can do it site. You go directly to GMT site.
Mm-hmm. Home.
Ah.
Site. Just do GMT site. GMT doc site or GMT site. One of them. Don't remember. Or either is doc site or GMT site, and you go directly to the site.
If you want to know all the options, you can do GMT docs. And that'll take you to the documentation of the docs module, right? So that'll give you all the options.
Docs squared. That's very fancy.
Some docception there.
Square.
Yeah. All right, that worked.
All right. So if we could send people to the breakout rooms now, that would.
We are back in the main session for what is called a wrap up, and I think what that means is that we're wrapping up the grid session, because I'm sure we're still working on that, I'm sure. So, but if you have any problems that you're running into, you can post them in Slack if they weren't resolved by your personal assistant in the break room.
Yeah, and also feel free to continue working on any of these and ask questions throughout the day tomorrow as well, or today for you, depending on the time zone. Since we're so spread out, the chances of one of us being awake and on the Slack are not small.
Absolutely.
Yeah, so for the grid session, again, I would say, as with all the others, go and try to dive into the GMT documentation and look at the resources that we put up on the course GitHub. Because it's very easy to get sucked down a GMT rabbit hole and try to tweak the plot endlessly. And you can basically do anything with the plots, given enough time and willpower. So it always pays off to try to tweak things a little bit and try to learn how to do certain things. Like it pays off at the end.
The other thing that saves you time is to not go for the highest resolution grid at once, because it takes a while to render and you're waiting around for a long time, and then I got to move it a little bit. So just do same thing for coastline. Do coarse coastlines, do coarse grids until you got the layout where you want it, and then you can up the resolution on the images. Yeah. So once you have the plot done, you can increase the resolution by changing the 2 characters that specify. So instead of doing 10M, if you do
01 M, you'll go from 10 arc minutes to 1 arc minutes, and that's all you had to change.
Yeah.
Yep. So I guess on my part, that's it. So I look forward to seeing the images that you'll post on Slack. And yeah, again, if you have any questions, feel free to post. I might only answer tomorrow because it's already 11 o'clock here, but 11 p.m. here.
Yeah, don't worry about posting the questions. We will get to them when we get to them. As you can see, we're all spread around the globe, but we will continue to answer questions for a few days after the workshop as well. We won't shut it down immediately, but yeah, so put your questions there. And if we need more information, we may ask you to open a GitHub issue if that's what it's going to take to delve into it. Mm-hmm. Sometimes it's hard to tell from just looking at a few lines or hearing what you described, what the problem is. Yeah. But we'll get to the bottom of it. We usually do. Mm-hmm.
Yeah, and after that, please join the GMT forum. It's very active. There's loads of people asking and answering questions. So if you have a question or if there's something that you want to see how to do, or just if you just want to keep in touch and see what we're up to, the forum is where we post all our updates and everything.
Yep, that's a good point. And the forum is also useful to introduce yourself and just asking even non-GMT questions about, where do I find a data set that'll just do this for me, for instance, because be someone there who knows, right? Yeah. And the people there range from very old gurus like myself to fresh newbies who just gotten their first command running. So it's a whole range. And so all of you can help people on that thing by answering questions. Plus you can get help there. So it takes a village, right? I mean, we're all in this together, and the more of us to contribute, the better it is for everybody. So that's sort of the game plan.
Yeah. And also, if you manage to make a figure that you're particularly proud of after blood, sweat, and tears, yes. Then we also have a place for you to post like the script and the figure that you made if you want to share your success stories with others, or if there's a big fail that you want to share as well. We also accept those. That's always good.
Yes.
All right. Any last words? Or anything else that we could do with before letting people go off and sleep or continue with their day?
Right. No, I can just say that tomorrow will be sort of similar, right? We're going to sort of follow the same recipe of a relatively short intro overview talks, followed by some sort of group exercises in the breakout rooms. And the hardest part for us is to stay on time, because this used to be a day-long session at on the physical site, like at Scripps, with 25 people, and scaling that to 100 people with 5 hours instead. It's a challenge for us too, and we're converging, but we're not quite there yet. It's hard to get the material through in a short time. So bear with us. We're trying to get this thing, give you just enough information so you can not hurt yourself, so you can make the figure. So that's the challenge. So I think we'll just leave the thing open in case someone has an inspired question, a few more minutes, and then Melissa will shut things down at noon Hawaiian time, which is what, 11 p.m. UTC or something. We can all go and get lunch, dinner, or a nap or sleep. Well deserved.
Thank you.
You're welcome.
Yeah, thank you
so much.
Thanks for playing.
Yeah, thanks everyone for putting up with a very long day.
And you're welcome to check out anytime. Because yes, thank you.
Bye. Bye. See you tomorrow.
See you tomorrow.
Mañana.
Amanhã.
That's right. You should know these things. There you go. Okay. See you folks tomorrow.
Yeah. See you.